Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to factor a number out of a polynomial in order to simplify the expression, how to recognize a binomial as a difference of squares, how to factor a binomial into a difference of squares, how to factor polynomials with a coefficient of 1 into a product of binomials, how to factor polynomials with coefficients greater than 1 into a product of binomials, how to recognize roots of a quadratic equation as being the x-intercepts of the equations, how to use factoring to determine the roots of a quadratic equation, how to use a quadratic formula to determine the roots of a quadratic equation, how to convert between trinomials and squared binomials, how to complete the square by splitting up the constants within a quadratic equation, how to use completing the square to determine the vertex of a quadratic equation, how to recognize patterns in the graphs of quadratic equations, how to determine the vertex of a quadratic equation, how to recognize the line of symmetry of a quadratic equation, and how to graph quadratic equations on the coordinate plane. How are we learning it? Through the Quadratics Review Notes and the Quadratics Review Assignment. When can we use this information? To examine problems in your life from different perspectives in order to find the best approach to simplify the problem, to determine the distance of a home run in the Major League Baseball Home Run Derby, and to rearrange your schedule in order to make space for another event. How do you know you learned it? By getting a score of 4 on the Quadratics Review Assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. After that, I'll give you time to complete the Quadratics Review Assignment. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to work on any incomplete assignments that you may have. Let's take a look now at the Quadratics Review Notes. The notes begin with the learning goals and success criteria. Understanding multiple forms of multiplication. So when we are multiplying two numbers together, particularly when one of them is a variable, we write them as joined together. So we write them like this. So we're multiplying 4 times x. So we write them joined together. We can also use parentheses to do this. So we can write 4 and then parentheses x. They mean exactly the same thing. They're just giving indication of multiplication. So distributive property. So it says, what would happen if we wanted to multiply 4 times 2 less than some unknown number? So instead of just being 4 times x, we want it to be 4 times some grouping of a number. So in this case, x minus 2. So we write it just like this, 4 times x minus 2. The distributive property states that we will multiply 4, so the number outside, by everything that's inside the parentheses. So this becomes 4 times x and 4 times negative 2. And then we can just go ahead and combine whatever terms we can combine at the end. So in this case, we get 4x minus 8. Because 4 times x is 4x, and 4 times negative 2 is negative 8. So then how do we solve something like this? X plus 4 times x minus 2. Well, maybe you heard of this term before, FOIL, which means first, outside, inside, last. So you multiply the firsts and then the outsides, so this one and this one, then the insides, then the last ones. Well, that might be what you've heard in the past, or maybe you haven't. But does it work for all polynomials? So can I do it with this? Now FOIL doesn't really help. So the easiest rule is multiply every term in the first one by every term in the second one. Pretty simple. So we take x and multiply it by x. We take x and multiply it by negative 2. Then that's all it for the x's. Now we do the 4. So 4 times x and then 4 times negative 2. And now we go ahead and combine these. So x times x is x squared. Negative 2 times x is negative 2x. 4 times x is 4x. And 4 times negative 2 is negative 8. Now we just combine the like terms. X squared, we have to leave that by itself. But we do have a negative 2x and a positive 4x. So we can combine those. So negative 2x plus 4x is positive 2x. So we get x squared plus 2x minus 8. So what about trinomials? So what if it's 3 terms? It's no different. We do the same thing. So we take x squared and multiply it by x squared. We take x squared and multiply it by 4x. We take x squared and multiply it by negative 6. Then we do it for the second term. Negative 3x times x squared. Negative 3x times 4x. Negative 3x times negative 6. And then we do it with the 2. 2 times x squared. 2 times 4x. 2 times negative 6. And this looks like a lot of stuff, but once we combine like terms, it shouldn't be so bad. So we get x squared times x squared is x to the fourth. We get x squared times 4x is 4x cubed. X squared times negative 6 is negative 6x squared, and so on. And we end up with this. Now we just combine like terms. So we're going to find all the x to the fourths. Well, this is the only x to the fourth. Then we find all the x cubes. Here's an x cubed, here's an x cubed. So we have 4x cubed minus 3x cubed. When we combine those, we just get a single x cubed. Then we do all the x squareds. Then we do all the x's. Then we do all the constants. And when we combine them, we end up with x to the fourth plus x cubed minus 16x squared plus 26x minus 12. Now factoring. Factoring is a term that means simplifying a problem by determining the factors of the expression. So we need to be able to pick out a common factor that exists within a number or a set of numbers. So in this case, let's just look at 36. What are the factors of 36? Well, we have 1, 2, 3, 4, 6, 9, 12, 18, and 36. These are factors because I can multiply all of these numbers by something and get 36. Or another way to look at it is 36 is divisible evenly by all of these numbers. So these are factors. So factoring is really just a reversal of the distributive property. For instance, with the distributive property, we had something that looked like this earlier. So we had 2 times x minus 4. Well, we multiply 2 times x and 2 times negative 4, and we get 2x minus 8. Now, if we were to factor this, we're looking for something that's in common between the two of them. Well, we know that 2x is divisible by 2 and negative 8 is divisible by 2. So I can pull that out, and I end up with 2 times x minus 4. So really it's the same thing. So I just divided each of them by 2 and put that outside. So factoring in this way is exactly the opposite of the distributive property. So let's look at some examples. So we have x squared minus 4x. So we're looking for something that's in common, that we can divide out of both of them. Well, we have an x in both of them, so we could divide that out. So when we do that, we have x times something is equal to x squared minus 4x. Well, we know that we need to pull out an x, so we're going to divide x squared by x. So x squared divided by x is just x. And then negative 4x divided by x is just negative 4. So we get x times x minus 4. Let's look at another example. We have x squared y minus 4xy squared. So we need to figure out what's in common. Well, we have a single x in common here, right? Because this x squared, there's not a squared here, so we can only pull one x out. And we have a y and a y squared, so we can pull one of those out as well. So we're going to pull out an x and a y. So we know that's what it's going to look like. xy times something is equal to this whole thing. Well, when we divide by an x, we're left with one x here. When we divide by a y, it takes the y away, so it's just 1. So all we're left with here is just an x. And then we have this minus 4, that stays. When we divide by x, the x goes away. And when we divide by y, we get just a single y. So we should end up with xy times x minus 4y. Let's look at another example. We have x squared minus 4. So we're looking for something that's in common. Well, all we have is an x here, and all we have is a constant here. So there's nothing in common there. So there's nothing we can factor out. So it's not factorable. So we just leave it as it is. So this is its most factored form for now. So what is a difference of squares? A difference of squares is subtraction of two terms that are perfect squares. For instance, x squared minus 1. So remember, difference means subtraction, so it's got to be subtraction. And each of these numbers needs to be a perfect square. Well, we know that x squared is the quantity x to the second power, and 1 is just 1 squared. So this is a difference of squares. So this would be an example. So how do we factor a difference of squares? we're going to use the following method. So anytime we start with something like this, and we have a number squared minus a number squared, it becomes a plus b times a minus b. Okay, so it's just something you have to memorize. So a squared minus b squared is equal to a plus b times a minus b. So let's look at an example. X squared minus 4. Well, if we rewrite this, if we put it in this form, this is really x squared minus 2 squared. So when we write that, we would write x plus 2 times x minus 2, and that would be our factored version. So look at another example. We have x squared minus 4. We said that that is... So let's check our work by distributing. So we said that x squared minus 4 is equal to x plus 2 times x minus 2. Well, let's go ahead and distribute this and see if it works. So we're going to multiply x times x and x times negative 2, and then 2 times x and then 2 times negative 2. So we get x squared here minus 2x plus 2x minus 4. We combine our like terms. Negative 2x plus 2x is just 0, so this becomes x squared minus 4. So we did it correctly. Let's look at another example. We have 25x squared minus 16. Well, 25x squared is really 5x squared, and 16 is really 4 squared. So we can rewrite this as 5x plus 4 times 5x minus 4. And that's our factored version. Let's look at another example. 25x to the 4th minus 16. Well, we have a power of 4 here, but is that still a perfect square? Well, we know 25 is a perfect square, and then x to the 4th is really x squared squared. So we can go ahead and enter that in. So this is 5x squared plus 4 times 5x squared minus 4. And that would be our difference of squares. Another example, 3x squared minus 12. Well, we can see that 3 is not a perfect square, and 12 is not a perfect square. However, we can see if we can use our method from yesterday as well. So we can see if we can factor out a common factor first. So is there anything in common between 3 and negative 12? Well, we can see that 3 is a factor of both 3 and negative 12. So let's go ahead and factor that out. So 3x squared divided by 3 is just x squared, and negative 12 divided by 3 is negative 4. Well, now we have this 3 here. Now we have a difference of squares inside the parentheses, so we can factor that. So this is really x squared and 2 squared. So this would be x plus 2 times x minus 2. So this becomes 3 times x plus 2 times x minus 2. Now, what is a quadratic? A quadratic is an expression or equation that is of this form: ax squared plus bx plus c. So notice the squared term is here, that we have an x squared, and we have some other x and then some constant. A, b, and c are all numbers, so those are not actually variables. So an example would be 3x squared plus 2x plus 4. That would be an example of a quadratic. So if I asked you to factor this quadratic, x squared plus 5x plus 4, the solution is going to be of this form: x plus m times x plus n, and m and n will be some number. So we need to figure out what numbers need to go in these two spots. And the way we do it is by using the x method. So we're looking at the same question, and here's what we do. We place c in the top. So c is 4, so this goes up here. Then we place b in the bottom. b is the middle number, so this goes here. Now we're going to write out the factors of c. So what are the factors of 4? Well, we have 1, 2, and 4. So those are my factors. Now I need to figure out which two of those numbers are going to multiply to equal 4 and add to equal 5. Well, I have 1 times 4 is 4, And when I add those two together, I also get 5. So I'm going to go ahead and put each of those in each of these sides. It doesn't matter which one goes where, as long as I have 1 and 4 on each side. Then I'm going to place those two values into the solution. So I start with x plus m times x plus n. I'm going to plug 1 in for one of them and 4 in for the other one. So I get x plus 4 times x plus 1. And that would be my solution. Let's look at another example. We have x squared minus 6x plus 8. So same thing, place c at the top. So c is 8, so that goes here. Place b in the bottom, which is negative 6. So that goes there. Then I'm going to write out the factors. What are the factors of 8? Well, I have 1, 2, 4, and 8. Now, which of those are going to multiply to equal 8 and add to get negative 6? Well, remember, these can be both positive or negative. So I'm looking at negative 1 times negative 8 is positive 8, but it's also equal to negative 9. So that's not the answer. What about this one? So negative 2 and negative 4. If I multiply those two together, I get positive 8. And when I add them together, I get negative 6. So that would be my solution. So it's negative 2 and negative 4. So I place those in my x and then add them to my solution, which started as x plus m times x plus n. Well, I'm going to plug in negative 2 for one of these and negative 4 for the other one. So I get x minus 4 times x minus 2. One more example. We have x squared minus 4x minus 12. Well, I place c at the top, which is negative 12. I place b at the bottom, which is negative 4. Then I write out the factors of c. So what numbers multiply to get 12? Well, I got 1, 2, 3, 4, 6, and 12. Now I need to find two numbers that multiply to equal negative 12 and add to get negative 4. So I know in order to get a negative, when I multiply, one of them has to be positive, one of them has to be negative. So one of these has got to get me close to 4. So if I do this, I have 2 and 6 are 4 away from each other. So I just need to make sure that when I add them, the bigger number is negative so that it stays negative. So I'm going to make this negative 6 and positive 2. When I multiply those together, I get negative 12. When I add them together, I get negative 4. So I go ahead and add those to my x. Then I place them into the solution. So I start with x plus m times x plus n. And then I'm going to plug negative 6 in for one of them and 2 in for the other one. And I get x minus 6 times x plus 2. Now what if the a value is not 1, like in the previous examples? So in this one, we have 5x squared minus 18x plus 9. Well, we're still going to use the x method, but we have to add a little bit to it later on. And this becomes the x box method. So the way we start is we're going to multiply a times c and put that in the top. So 5 times 9 is 45. And then we put b in the bottom, just like before, so that's negative 18. And then we're going to write out the factors of a times c. So what are the factors of 45? Well, we can see that the factors are 1, 3, 5, 9, 15, and 45. So now which one of those is going to add up to be negative 18? Well, this is positive, so we know that they have to match. The signs have to match. So we need two of them that are going to add up to be 18, which we can see would be 3 and 15. So that would be negative 3 and negative 15, because that'll give us negative 18 total. So we have negative 15, and this should be negative 3. Now we're going to do the box part. So that's the x part. Now we're going to do the box part. So we're going to make a table with 4 squares, just like this. And we're going to place ax squared in the top left box. So that's 5x squared. So that goes here in the top left. Then in the bottom right, we're going to put c, which is 9. So that goes there. Now we're going to place negative 15x and 3x into each one of the boxes. And it doesn't matter which one you place it in. So we'll put negative 15 there and 3x here. Now we're going to factor out what we can, trying to find a common factor. So between 5x squared and 15x, there's a 5x in common. So that's what we would factor out. So we'll go ahead and just put it at the top of the box. Then we'll do this one, 3x and 9. Well, 3 is in common between those two, so we'll put a 3 at the top. Then we go crossways. So we have 5x squared and 3x. Well, the only thing in common there is an x. And then 15x and 9. Well, we have a 3 in common there. So now we have 5x and 3 and x and 3. And now we just place it into our solution. And now we're just going to check the signs to make sure they're correct. We know that the signs need to match so that it's 9, which they do here. And we need to make sure that we add up to be negative 18. So this is 5 times negative 3 is negative 15, minus 3 is negative 18. So we did it correctly. Let's look at another example. We have 2x squared minus 11x plus 15. So again, put a times c in the top. So a times c is 2 times 15 is 30. And put b in the bottom, which is negative 11. So we need two numbers that multiply to get 30 and add to get negative 11. So we write out the factors of 30, and we get 1, 2, 3, 5, 6, 10, 15, and 30. Well, we know that 30 is positive, so then we need to have two numbers that are both the same sign, which add to get negative 11. Well, 5 and 6 gives us 11. So if they're both negative, that would give us negative 11. So this would be negative 5 and negative 6. So we go ahead and place that there. Now we move to the box part. So there's our box, and we put in ax squared here in the top left. So this is 2x squared. And we place c in here in the bottom right. So that's 15, so that goes there. Then we place these parts here. So negative 5x and negative 6x go in each of these boxes. And again, it doesn't matter which one goes where. So there we go. Now we just need to figure out what the common factors are. So we'll start here. 2x squared and negative 5x. Well, the only thing we have in common there is x. And we have negative 6 and 15. Well, they have a 3 in common. Then here we have 2x squared minus 6x. Well, we have a 2x in common. And then 5x and 15 has a 5 in common. So we have x minus 3 and 2x minus 5. And we place those into our solution. So now we have 2x minus 5 and x minus 3 as our answer. Now there's a video here using Symbol Lab to show you how you can check your work with factoring. So go ahead and watch that video. Okay, what are roots? Roots of functions are the points on the graph of a function where the y values are 0. Another way to think of this is where the graph touches the x-axis. So we call these roots, we also call them sometimes roots, zeros, solutions, and x-intercepts. So all of those are different things that roots can be called in different ways. So what does a root look like? It's an x-intercept, or where the line crosses the x-axis. So it crosses here, and then it comes back down and crosses here. We call those the roots. So how do we find the roots of a quadratic? Well, the first step is factor the quadratic. So factor it any way you can, and then solve for the roots. So when we get here, we have x squared minus 5x plus 4. We would use our magic x, and once we do that, we should see that x minus 4 times x minus 1 is equal to 0. So we factor this out. Now we take each of those parts and set them equal to 0. So x minus 4 is equal to 0, and x minus 1 is equal to 0. Now we just solve for x. So we add 4 to both sides, and we get x equals 4. We add 1 to both sides, and we get x equals 1. So the zeros, or the roots, or the x-intercepts, whatever you want to call them, those ones for this equation are x equals 4 and x equals 1. Let's look at another example. We have x squared minus 5x is equal to 0. So again, we factor this, and we can pull an x out of this. So we get x times x minus 5 is equal to 0. Now we set each of those parts equal to 0, and that includes the x. So x can equal 0, and x minus 5 can equal 0. Well, x minus 0 just stays as is. It's just x equals 0. So that's one of the roots. The second one now, we add 5 to both sides, and we get x is equal to 5. So x equals 0 and x equals 5 are the roots for this quadratic. Now what about quadratics that can't be factored? So not everything comes out evenly. So not all quadratics can be factored. For instance, this one, x squared minus 5x plus 3 equals 0. This is a non-factorable quadratic. So when we get these non-factorable quadratics, we have to use what's called the quadratic formula. So what is the quadratic formula? Quadratics will always appear as ax squared plus bx plus c equals 0. And from that, we can create the quadratic formula, which says this: x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's take a look at an example of how that works. First thing we need to know before we get started, though, is what is the discriminant? The discriminant is the part under the square root. If the value under the square root is positive, then we have two roots. And if the value under the square root symbol is negative, there are no roots. So that's why we call it the discriminant, because it discriminates here against negative roots. So if it ends up negative, then we know we don't have to do any other work. It's no solution. Okay, so let's take a look here. So we're given x squared minus 5x plus 3 is equal to 0. And we're asked to use the quadratic formula. So we're going to plug in. So negative b, so that becomes negative 5, which is positive 5. Plus or minus negative 5 squared minus 4 times a, which is 1, times c, which is 3, over 2 times a, which is 1. And we end up with this. So all I did was take and plug in to the formula. Now we can go ahead and start to work the problem. So negative 5 is just positive 5. Negative 5 squared is positive 25. And then negative 4 times 1 is negative 4 times 3 is negative 12. And then 2 times 1 is 2. So we end up with this. Now we just simplify under the radical. So 25 minus 12 is 13. So we get 5 plus or minus square root of 13 over 2. Now, notice there is no perfect square root of 13, so we just leave it as is. And we make this a plus, so this is 5 plus square root of 13 over 2. And then the minus part comes in, so this is 5 minus square root of 13 over 2. So anytime you see this plus or minus, that means we're going to do two things. We're going to add it and then subtract it. So we're going to do both to it. So here's our addition, here's our subtraction. These are our two roots. So look at another example. We have 2x squared minus 5x plus 3 is equal to 0. So we're going to plug it into the formula. So we plug negative 5 in for b. We plug, again, negative 5 in for b here. We plug 2 in for a, and we plug 3 in for c, and then we plug 2 in for a down at the bottom. We get this. We simplify. Negative 5 is just positive 5. Square root of 5 squared is 25. And then negative 4 times 2 is negative 8 times 3 is negative 24. And then 2 times 2 is 4. So we end up with 5 plus or minus 25 minus 24 over 4. Well, 25 minus 24 is 1. And then the square root of 1 is just 1. So now we end up with 5 plus or minus 1 over 4. So now we're going to go ahead and solve this. So this is 5 plus 1, which is 6 over 4. 6 over 4 is equal to 3 halves. And then we do it again. 5 minus 1 is 4 over 4, which is equal to 1. So our roots for this one would be 3 halves and 1. Let's look at one more example. We have 3x squared minus 5x plus 3 is equal to 0. So we plug everything in, and we end up with negative 5 plus or minus the square root of negative 5 squared minus 4 times 3 times 3 over 2 times 3. And when we simplify that, negative 5 is positive 5. Negative 5 squared is just 25. And then negative 4 times 3 is negative 12. Times 3 is negative 36. and then 2 times 3 is 6. So we end up with 5 plus or minus 25 minus 36 over 6. Well, what we should notice is when we combine these, we end up with negative 11. Well, going back to our idea of a discriminant, we know that if there is a negative under the radical, there are no roots. So in this case, we would just say there are no roots, or we'd say no solutions. So how do we know that there are no roots? If we take this equation and put it into Desmos, it looks like this. Well, we can see that it still forms a parabola, just like all the others do, right? That U shape. But notice it's above the x-axis and it never comes down and touches. So there are no roots there. Okay, just a reminder, you need to simplify under the radical all the time. So let's say you end up with square root of 12 under the square root symbol. You always need to simplify it as much as possible. And the way you do that is you're going to try to find the greatest square factor. So for instance, what we think about the factors of 12, and we recognize that the factors are 1, 2, 3, 4, 6, and 12. And we want to pick out which ones are perfect squares. Well, we know that 1 and 4 are perfect squares, but we only want the biggest one, so 4 is the biggest perfect square. So that's really 4 times 3. So we could take the square root of 4. The square root of 4 is 2. So this becomes 2, and then we leave whatever's left under the square root, which is 3. So this becomes 2 square root of 3. Simplifying fractions, remember once you're done and you get your answer, make sure that you simplify the fractions as much as possible. So let's say I get 4 plus or minus 2 times the square root of 3 over 2. If this value in the denominator goes into both evenly, then you need to go ahead and divide it. If it only goes into one, then you leave it, because it has to go into both. So 4 divided by 2 is 2, and 2 square root of 3 divided by 2 is just square root of 3. So we end up with 2 plus or minus the square root of 3. There's a video here now that you can watch that shows you how to check your roots for quadratic equations using Desmos. So go ahead and watch that video. Let's talk now about how we can use Desmos to check the roots of a quadratic equation. So first of all, I'm going to go to desmos.com, and then I'm going to go to where it says graphing calculator. And if you notice, it should take you to a page that looks like this, where it'll have the graph on this side. We just need to enter the equation over here on the left. So let's go ahead and do that. So let's say it's y equals 2x squared plus 5x minus 2. Well, as we can see, we have our graph that pops up here, and there's 2 places where it crosses the x-axis. That represents the roots. So if I click on it, I'm going to find the x-coordinate, which is right here, and I can see that the root for this one on this side is negative 2.851. And if I go to the other side, the root on this side is 0.351. So no matter which equation I type in, so I can type in y equals x squared. There's my second one. I can find where it touches the x-axis right here, and if I click on it, it will give me the root, which is the x-coordinate of that point. So this is how you would use Desmos to check the roots for a given quadratic. Now, what does the graph of a quadratic look like? The graphs of quadratics are parabolas, or U-shaped curves. They look like this. So it forms this perfect U shape and goes down and then comes back up. And it could also go the other direction. It could start by going up and then return down. So these are quadratics. So how do we graph quadratics? Well, we need certain key pieces of information. The first one is, what direction does it open? So is it starting by going down and then coming back up, or is it starting by going up and then coming back down? So we need to know which direction it opens. We need to know the roots. So where does it cross the x-axis? We need to know the vertex. We need to know the line of symmetry. So line of symmetry, it's going to form a perfect U shape, so it's going to be the same distance from that line of symmetry on each side. So it should look like a perfect reflection. We need to know the maximum and minimum. We need to know the domain and range. So let's look at each of these components. First of all, the direction it opens. So the first one is opens up. Notice, as we go up, it gets wider and wider. That's opening up. Now, opening down would be the opposite. So here, it's getting wider and wider as we go down. So that's opening down. So opens up, opens down. Now, the graph opens up if the lead coefficient, so the number in front of the x squared term, is positive. So as long as the number in front of the x squared term is positive, it opens up. For instance, 3x squared minus 4x plus 3. The 3 is positive, opens up. Now, it's going to open down if the lead coefficient is negative. For instance, negative 3x squared plus 4x plus 3. So it doesn't matter that all these terms are positive. If this term here is negative, the entire thing is going to flip and open down. Now, the line of symmetry. So if we draw a vertical line right through the vertex, right through here, we should be able to see a mirrored image. So if we look here, here's my vertical line right through the vertex. And notice this point here and this point here should be exactly the same distance from this line. If I pick any other point, this one and this one, they should be exactly the same distance from the line of symmetry. So it's reflected. If I were to take this and flip it over, it should land directly on this one. So this is our line of symmetry. And the line of symmetry always is the x value of the vertex. So my h here, that would be my exact line of symmetry. So in this case, let's say that our vertex is at 2, negative 3. So our line of symmetry would be at x equals 2. Now, first of all, what is the vertex of a quadratic? The vertex of a quadratic is the point where the graph changes directions. So what that means is it might start by going up, but then it's going to change directions and start coming back down. So that is a change of direction. So example would be right here, we're going up until we reach this point right here. As soon as we reach this point, we start going back down. This point right here would be considered the vertex. Now, how do we find the vertex? The vertex of a parabola is found by using this formula. A times x minus h squared plus k. Now, this should look pretty familiar because this is basically the completing the square of a quadratic. So the h value is the x coordinate. Now, what is a perfect square trinomial? A perfect square trinomial is a trinomial that looks like this. X squared plus 2bx plus b squared. So b is some value. It'll be actually a constant. And the number here should be exactly double it. So an example of this would be x squared plus 6x plus 9. So we know that 9 is 3 squared, and 3 times 2 is 6. So this is a perfect square trinomial. When we factor this, we recognize that this becomes x plus 3 times x plus 3, or x plus 3 squared. We'll look at another example. Now we have 2x squared minus 12x minus 4. So we're going to factor out the lead coefficient because we can't complete the square if there's a number in front. So we're going to divide everything by 2. So now we get 2 times x squared minus 6x minus 2. Now we go through our steps like we did before. So we take negative 6 and divide it in half. Well, negative 6 divided by 2 is negative 3. We square that and we get 9. So that's what we need it to be. But instead we have negative 2. So we need to rewrite this. How do we get from 9 to negative 2? Well, we subtract 11. So now we have 2 times x squared minus 6x plus 9 minus 11. Now we rewrite it as a perfect square trinomial. So we get x squared minus 6x plus 9, and that becomes x minus 3 squared. And then we take this part and we just need to distribute the 2 back to it. So 2 times negative 11 is negative 22. So we get 2x minus 3 squared minus 22. Now there's a video here that shows you how you can use Symbol Lab to help check your work when completing the square. So go ahead and watch that video now. Let's take a look now at how we can use Symbolab to check our work when working with completing the square. So we go to Symbolab and we go to the completing the square calculator. We're going to go here and type in our equation. So let's say it's x squared minus 4x plus 9. We're going to go ahead and click go. It shows us what it should be at the end, which is x minus 2 squared plus 5. And if we scroll down, it'll actually show us the steps of how to get there. So here's how we would do that. So this is one way that you can check your work when completing the square using Symbolab. Now how do we find the vertex then? So once we've completed the square, now we just plug this in. So we recognize that this is the h value, and it's always supposed to be minus h. So my h value is just here, so this is going to be positive. So it's positive 3. And then my k value is supposed to be positive, so this one's negative, so it would be minus 22. So my vertex would then be 3, negative 22. So that's how I find the vertex once I've completed the square. Now there's a video here showing you how you can use Desmos to check your work when trying to find the vertex of a quadratic. So go ahead and watch that video now. Now let's take a look at how we can use Desmos to check our work when checking the location of the vertex of a quadratic. So we go to Desmos.com and we're going to click on Graphing Calculator. Now whether it's in standard form or vertex form, we can type it in either way to check our work. So we can type in y equals 2x squared minus 4x plus 3. And we can see the exact location of the vertex. And if we click on it, it'll tell us exactly where it is. So it's at x equals 1, y equals 1. We could also do it in vertex form. So y equals x minus 3 squared plus 5. And we can see here that our vertex, if we click on it, is at 3, 5. So this is how you can use Desmos to check your work when trying to find the location of the vertex of a quadratic. Now, how do we actually graph the quadratics? First step is plot the vertex. So we need to find the vertex and then plot that. Then we plot the roots or other points. So if there's no roots or if the roots aren't easy to find, that's okay. Use a table and find 2 other points. So plug in values for x, solve for y, and plug those points in. Notice that it should be reflected. So whatever point I have on one side, I can just copy it to the other side. I don't actually have to solve for it anymore. Then I just connect the dots and form my U shape. So for instance, I have y equals x squared. So I plot the vertex. I should notice that this is really x plus 0 squared. So my vertex should be here at 0, 0. Then I plot 2 other points. So when x is 1, 1 squared is 1. So when x is 1, y is 1. So I plot that. Now I should notice that it's going to be exactly the same distance over here. So I went to the right one, up one. So I'm going to go the same thing the other way. So to the left one and up one. And plot my point. Then I'm going to use another point. So now I plug in 2 for x. So when x is 2, y is 2 squared, which is 4. So when x is 2, y is 4. So I plot that point. Then I do the same thing. So I went to the left 2, up 4, right there. Plotted that one. Now I can just connect the dots, and there's my U shape. Now there's a video here that shows you how you can check the graphs of quadratics using Desmos, so go ahead and watch that video. Now let's take a look at how we can use Desmos to check our work when checking the location of the vertex of a quadratic. So we go to Desmos.com, and we're going to click on Graphing Calculator. Now, whether it's in standard form or vertex form, we can type it in either way to check our work. So we can type in y equals 2x squared minus 4x plus 3. And we can see the exact location of the vertex. And if we click on it, it'll tell us exactly where it is. So it's at x equals 1, y equals 1. We could also do it in vertex form. So y equals x minus 3 squared plus 5. And we can see here that our vertex, if we click on it, is at 3, 5. So this is how you can use Desmos to check your work when trying to find the location of the vertex of a quadratic. Let's take a look now at the Quadratics review assignment. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. The first one says 5x squared minus x minus 18, and it wants us to factor it. Well, we know that we're going to have a 5x and an x to get 5x squared. So we should end up with a 5x and an x. So it could be one of these three. And then we need two numbers that multiply to get negative 18. So we have, for instance, 9 and 2 or 6 and 3. Well, we have 6 and 3 and 9 and 2. So all of these are possibilities. But when we do that, we get 5 times 3 is 15 minus 6 is 9, which is not negative 1x. So that one's out, so it can't be this one. Let's try here. If we multiply 5x times 9, we get 45x, and minus 2x is 43x, which is not correct either. How about here? 5x times negative 2 is negative 10, plus 9x is negative 1x, so this would be our correct answer. So we'll go ahead and mark that one as correct. We'll scroll down to the next one. Next one says factor the expression 2x squared minus 4x. Well, we can see that there's a 2 in common and an x in common, so we're going to pull out a 2 and an x. And when we do that, we're left with just x here and minus 2. So we should have 2x times x minus 2, which is this one here. And we'll continue to answer all of these until we get to the end. Once you get to the end, go ahead and click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.